From the previous section, we know that we're not allowed to have a radical in the denominator of a fraction. And when we do, we want to eliminate that radical in the denominator by rationalizing. If we have a radical expression in the denominator, we have to use another method of eliminating that radical, and that is finding the conjugate. And here's an example of a conjugate. If the following expression were given in the denominator, find the conjugate to be used to simplify the expression. All we need to do is take the exact expression in the denominator and change the sign. Therefore, I need to multiply this expression, which would be in the denominator of a fraction, and I'd multiply it by the conjugate, which would just be 3 plus 2 square roots of 5. I just rewrite the expression and change the sign. If this were in the denominator of a fraction, its conjugate would be 2 square roots of 3 minus 7. Here's an example to determine why a conjugate eliminates the radical in the denominator of a fraction. Here we want to multiply the pair of the conjugates. If this was our expression in the denominator of a fraction, I need to multiply it by its conjugate. So when I do so, I FOIL. First is 36. Outer is a negative 6 square roots of 7. Inner is a positive 6 square roots of 7. And my last is a negative square root of 49. In other words, this factors into a difference of squares. And we know when we FOIL a difference of squares, it eliminates my middle term. And in that case, it eliminates my radical. So I bring down my 36. I have a positive 6 square roots of 7 and a negative 6 square roots of 7. Therefore, when I combine, those go to 0, or they eliminate. And I know the square root of 49 is 7. And when I do the final simplification, I get 29. And now the denominator of my fraction would not have a radical, it would have a real number. Again, I want to multiply each pair of conjugates. If this expression was in the denominator of a fraction, I'd need to multiply the top of that fraction and the bottom of the fraction by its conjugate. Its conjugate is the same expression, except I changed the sign. Now all I need to do is to FOIL that expression. First term, square root of 3 times square root of 3 is the square root of 9. My outer term is a positive square roots of 6. My inner term is a negative square roots of 6. And my last term is a negative square root of 4. Now I simplify. Square root of 9 is 3. My middle terms drop out. Square root of 4 is 2. That's a minus 2. And my real number in the denominator would be 1. Following the same procedure, if this expression was in the denominator of my fraction, I'd multiply the top and bottom of that fraction by its conjugate. And to do so, again, I would FOIL. My first term would be 9 square roots of 4. My outer term would be 12 square roots of 2, positive. My inner term would be a negative 12 square roots of 2. And my last term would be a negative 16. Combining like terms, let's simplify first. That gives me the square root of 4 is 2. 2 times 9 is 18. My middle terms will drop out. They're like terms. Bring down my last term, which is a negative 16. And simplify, and I get a real number in my denominator. I would continue by multiplying that same conjugate here to the numerator of my fraction. Here's a complete example. They want me to rationalize each denominator and simplify the answer. I have a radical expression in my denominator, so to simplify this, I need to rationalize, or in this case, I need to multiply the numerator and the denominator by its conjugate. And we know the conjugate is the same expression, but I just changed the sign. So it's 3 square roots of 10 plus 5. And I also multiply the numerator by that same expression. 3 square roots of 10 plus 5. Multiply the top and bottom by the conjugate. I use the distributive property in the numerator, which gives me a negative 21 square roots of 10 minus 35. On the denominator, I'm going to FOIL. My first term is 9 square roots of 100. My outer term is 15 square roots of 10. My inner term is a negative 15 square roots of 10. And my last term is a negative 25. And I'm going to simplify. It gives me a negative 21 square roots of 10 minus 35 over my middle terms we know are going to drop out. The square root of 100 is 10. 10 times 9 is 90. And 90 minus 25 is going to give me 65. Now I wanted to see if I can simplify my coefficients and constants any further. So I'm going to factor the numerator if possible. And here I can take out a negative 7, and that will leave me a positive 3 square roots of 10 plus 5. And that's all over 65. Then I would verify if these two could simplify. In this case, they can't, but at least I went the next step to see if I could simplify that fraction. Again, I want to simplify or rationalize this denominator. To do so, this is an expression, so I need to find a conjugate. I'm going to multiply the numerator by the conjugate, which is 2 minus 2 square roots of 7 over 2 minus 2 square roots of 7. In this situation, I need to FOIL in the numerator and the denominator. In the numerator, that's going to give me my first term, which is going to give me 2. My outer term, which is a negative 2 square roots of 7. My inner term, which is a positive 6 square roots of 7. And my last term, which is a negative 6 square roots of 49. Over, again, I'll FOIL on the denominator. First term is 4. Outer term is a minus 4 square roots of 7. Inner term is a positive 4 square roots of 7. And my last term is a negative 4 square roots of 49. Let's simplify both. In the numerator, that gives me 2. When I combine like terms, that's going to give me a positive 4 square roots of 7. And my last term is going to be a negative square root of 49 is 7 times 6, which is a negative 42. My denominator, my 4. My middle terms are going to drop out. And that leaves me the square root of 49, which is 7 times a negative 4, which is a negative 28. Let's simplify again. That's going to give me 2 minus 42, which is a negative 40, plus 4 square roots of 7 over a negative 24. Now, I want to see if I can factor the numerator. I'm going to factor out here a negative 4. That's going to give me a positive 10 minus the square root of 7 over a negative 24. And finally, that's going to simplify. Negative and a negative, the negatives are going to cancel out. 4 is going to cancel to 24, which is 6. And my final answer is 10 minus the square root of 7 over 6. On this example, we're asked to simplify rational all denominators and assume all variables are positive. Here I don't have like terms, so let's begin by simplifying each radical. So that's going to give me 2 square roots of 9 times 3 times x squared times x plus a negative 3 square roots of 4 times 3 times x squared times x. Now let's simplify each radical. The square root of 9 is 3. 3 times 2 is 6. Square root of x squared is x. And the radical is going to be 3x. I'm going to have a minus sign. Square root of 4 is 2. 2 times 3 is 6. Square root of x squared is going to be x. And inside the radical is going to be 3x. Now, when I take a look at my terms, I realize they're like terms. The index on each is the same, which is 2, and the radicands are the same. So now I can just combine like terms. 6x minus 6x is 0. 0 square roots of 3, when you multiply, is 0. Again, I want to simplify. In this case, I'm going to have to rationalize. I'm going to multiply by a radical in such a way that the cube root of x will simplify to a variable. In this case, it will be the cube root of x squared. I'm going to have to distribute in the numerator, which is going to give me 3 cube roots of x squared plus the cube root of x cubed over, when I multiply the denominators, I'm going to get the cube root of x cubed. Now I can simplify. I'm going to have the cube root of x squared is still the cube root of x squared, so that's 3 cube roots of x squared plus the cube root of x cubed is just x over the cube root of x cubed is x. I can't factor anything out of the numerator, therefore this is simplified.